Section 1-3 Energy in the Atmosphere. Heat plays a big role in Earth's weather. That heat comes to us as energy from the sun. The light from the sun interacts with the ground and atmosphere to produce heat, which drives our weather. Now, light travels through space from the sun to the Earth. Light is the only thing that travels through space to get to us. Heat cannot go through space because it needs something to move through. Since space is the absence of material, that means that it can't travel through there. Light that we get from the sun is broken up into three parts: infrared, visible, and ultraviolet. Those are the main three types of light that the sun sends us. Now, two terms that we need to know the difference of is temperature and heat. Now, temperature is a measure of energy of motion of a substance. So think about it this way: a object that is very, very hot is going to vibrate a lot, where an object that is cold is going to vibrate a very, very little. See, molecules are constantly in motion, including even the molecules that make up the desk in front of you. They are constantly moving around, vibrating. Now, molecules that move more have a higher temperature. Molecules move less, lower temperature. Now, thermal energy is total energy of motion, particles, substance. That includes all of it. Heat is the energy that's transferred between two objects at different temperatures. Because if these two molecules were to come into contact, they would try to even out, and so the one that's more energetic would give up energy to the one that's least energetic until they get even. The energy that gets transferred is called heat. So temperature, measure motion, substance. Higher temperature, move more quickly. Lower temperature, move less quickly. So again, the sun sends us three main types of light: infrared, visible, and ultraviolet. That's the only thing that travels through space. Infrared is lowest energy, ultraviolet is highest energy. Red light has lower energy than blue light. And we know the colors: red, orange, yellow, green, blue, and violet. So violet end, or we do just call it the blue end, has high energy, whereas red end has low energy. Now, light is a type of electromagnetic wave. What that means is light is a particle that moves through space and also a wave that vibrates. Red light has lower energy. It also has what we call lower frequency, which just means it vibrates less often. Violet has higher energy, higher frequency, which means it vibrates a lot more. Now, light from the sun interacts with the earth in different ways. About 50% or half is absorbed by the surface and then re-released as heat. 20% absorbed by the atmosphere. A lot of that we could think about being absorbed by the ozone layer. 5% is reflected by the surface back into the atmosphere. And about a quarter, 25%, reflected by dust, clouds, and gases in the air back into space. So this is how much light gets reflected right away. Part of the reason why we can see the Earth in space, like say when we're on the moon, is because of that 30% of the light that it does get resent. So this is a little graphic talking about what happens to light. So all the energy we have on Earth pretty much comes from the sun. So here's the sunlight coming in. Some of it, and these numbers are a little different than the ones I just stated, they're kind of averages. Some is reflected by the atmosphere, some is reflected by clouds, some is reflected by the surface. The rest gets absorbed by the land and oceans. Now, can't forget about the oceans, they're a big part. The stuff that gets absorbed can get retransmitted as heat. Some of it goes as carried to clouds atmosphere by latent heat and water vapor. Some is just absorbed by the atmosphere. Some goes back into space. So energy is in constant motion. So energy travels from the sun to us. The Earth absorbs some of it. Some of it gets reflected back right away. Eventually, a lot of the energy does go back out in space because we keep getting more energy coming in. Now, the ozone layer absorbs ultraviolet light, and so that heats up part of our atmosphere. And then we have other gases in our atmosphere that kind of slow down this re-release of energy. So the energy, this energy here, that gets sent back up by the oceans and the ground, some of that gets slowed down by the layer of greenhouse gases. Oops, sorry. So greenhouse gases slow that down and pretty much trap in that heat. Now, the interaction of light in our atmosphere also produces blue skies, red sunsets, and the main reason for this is that, again, blue is higher energy, it vibrates more, red is lower energy, it vibrates less. And so here's the surface of the Earth, and we have all these molecules making up the atmosphere of the Earth. Now, as blue light comes in, that light, because it's higher energy, actually interacts with molecules in our atmosphere more frequently, and so it can get scattered. And so it gets sent around to all the other places, and then from there it can travel down to Earth. And so if you're an observer on Earth, you see blue light coming to you from all parts of the sky. So you look up at the sky, it looks blue. That light that is blue coming from the sky originally came from the sun. Now, a big difference, let me just change colors real quick. Let's go to red. Is red light doesn't vibrate as much, and so it doesn't interact as much, and so it travels mostly through. It barely gets scattered by the molecules in the atmosphere at all, and so our sun looks reddish. And actually, we can break up all three lights into three main colors: red, green, and blue. Blue gets scattered a lot, and so most of the time that red and the green is what travels through, and so that's why we see an orangish yellowish sun. Now at night, at sunset and sunrise, um, pretty much what happens then again are three main colors. These two get scattered, while this guy passes straight through. So the blue and the green, you'll look at the sky, it does look bluish green. The sun looks very red because that's the main color that's coming to us without getting interfered by the atmosphere. Also, how the distribution of sunlight on Earth's surface changes is the cause of the seasons. Wintertime, we get less sunlight, and summertime, we get more sunlight, and it's by how direct the sunlight is. So I'm going to write that again. How direct the sunlight is. That determines our seasons. Now, energy is transferred in three ways: radiation, conduction, convection. Conduction, direct transfer of heat from one substance to another in contact. So contact is very important for conduction. Convection is movement of a fluid transfers heat. Hot air rises, whoop, cold air falls, and hot air rises because it's less dense. Cold air falls because it's more dense, and that carries energy with it. So that's convection. Happens in the air, happens in water. Look at a pot of boiling water sometime. You'll see this little current. Drop a noodle in early. As soon as it starts kind of boiling, even right before then, you'll see this up and down motion in the water. Radiation is direct transfer of energy by electromagnetic waves. Light is another word we could use here. Here, I'll just write over that with the word light. Most energy you feel travels from the sun as infrared. So here's a nice little graphic talking about the three different ways. Conduction is contact, so your hand is in contact with the handle, so you're going to feel hot. Convection, we have the hot stuff rises, the cooler stuff falls. Hot stuff rises because it is less dense. Colder stuff falls because it's more dense. And then radiation is that light that travels outward. All three of these working together to heat the troposphere: radiation, conduction, convection. The surface is heated by radiation. Air in contact is heated by conduction. Hot air rises, carrying heat with it through convection, and then we get some radiation back. So again, radiation down to the ground. Then we get convection happening up and down. So that carries some heat, and then some radiation bounces back. And of course, all the air that's in the bottom here is in contact with the ground, and that gets heated through conduction. You have to think about the energy is in constant motion in our atmosphere, and the reason we get such powerful thunderstorms in the summertime is because there's such powerful convection currents taking place. Now, the greenhouse effect is something that's very important for us to understand. Is not the same thing as global warming. Is something different. The greenhouse effect is a trapping of heat that is radiated out from the planet's surface by greenhouse gases in the atmosphere. It moderates the planet's temperature. Without the greenhouse effect, our planet would get very, very, very hot and then very, very, very cold. Primary greenhouse gases are water vapor, so that's our number one, carbon dioxide number two, methane is number three, and nitrous oxide and ozone also work in there. Carbon dioxide, this is the one that humans have been producing a ton of since the Industrial Revolution. But even before that, there's been carbon dioxide in our atmosphere. Water vapor changes a lot, but when we talk about humidity, it feels warmer. Same thing happens in your house. These three gases here are the main greenhouse gases. Without them, in our atmosphere, at least some of them, it would get very, very cold at night, and our average temperature would be below freezing all the time.